Hey everybody. Um, so now we're starting chapter 6.2. And so this section isn't as long as the others, but it just basically adds a little bit to what we did last time. So in this section, solving is a little bit trickier. A little bit tricky. And the reason is because not only does it involve some basic algebraic manipulation, just like the problems from last time, you had to do a little bit of algebra before you could do trig. But it also involves some trig identities. Okay, so basically it's adding that to what we did last time. Also, since we already know that there's infinite solutions, we already know that. So in this case, in this section, they kind of drop the whole of 360k to pi k, and they only want answers between 0 and, not equal to, but they want answers between 0 and 360, or 0 and 2 pi. So that's kind of makes it a little bit easier in this section. So basically there's no plus 360k. Here there's no plus 2 pi k. Okay, because we already know that. And so they don't want you to just, if you know what the answers are, you just add those to it and you get all the answers. Anyway, so let's do this first example. It says solve 2 cosine x minus 1 equals secant of x. And so our first part of this is we're going to do some trig identities. Namely, I know what secant x really is. This is really 2 cosine of x minus 1 is equal to 1 over cosine of x. Right? Now, I don't like denominators, so we don't like denominators, so we're going to multiply both sides by cosine of x. Okay? When we multiply sides, you multiply the entire side. So in algebra, a lot of people make this mistake. But you have to multiply the entire side. So it's the entire side times cosine, the entire side times cosine. You don't pick and choose what you multiply by cosine. It's the entire thing. So if I distribute the cosine across, I'll get 2 cosine squared x minus cosine of x. And on the right side, the cosines cancel. So I'm left with just 1. Alrighty. Now this ends up being a quadratic, meaning that I can subtract 1 from both sides. So I have 2 cosine squared x minus cosine x minus 1 equals 0. And you're going to see a lot of quadratics like this in this section. And fortunately, they're pretty easy to factor if they're factorable. For cosine, there's only one way that I can get, if it's a clean factor, there's only one way I can get 2 cosine x, cosine squared x. And that's with 2 cosine x and cosine. As far as getting a 1, there's really only one way to do that. These have to be 1 and 1. Now the problem is, what do the signs need to be in order for it to work out? So is it plus or minus? Is it plus or minus? Well, that's what we got to figure out. So this is where we kind of do it in our head. First times first gives me 2 cosine squared x. And then I want the 2 cosine x to be negative. So I'm going to put the minus right here. That gives me, so first times first is 2 cosine squared x, outer. 2 cosine x times negative 1 is negative 2. But then I can add 1 plus cosine x to get the minus cosine x. And then 1 times negative 1 is negative 1. Now, if you don't like doing this, if this is, you can always use the quadratic formula, and it'll work out. But anyway, so this is factorable. Let me shrink it up a bit. So this gives me 2 cosine x plus 1 equals 0. Cosine x minus 1 equals 0. So cosine x is equal to negative 1/2. I subtract 1 divided by 2. And cosine x is equal to 1. So these are my two answers that I'm left with. And this is where we go to our grids. So cosine of x is equal to negative 1/2. And the other one is cosine of x is equal to 1. Well, I know cosine is positive, positive on the right, negative on the left, positive on the right, negative on the left. And so for cosine of x to equal negative 1/2, again, that's where memorizing your trig tables will come in handy. And since I didn't write it at the start, might as well write it now. Oop. So whenever you're doing a test, it's always a good idea to write out your little trig table in the beginning. So I have 0, wait, are we in radians? We're in radians. So 0, pi over 6, pi over 4, pi over 3, pi over 2. So I have 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. And then here this just goes in reverse order. And remember that these are reference angles. All right, so cosine is 1/2. Well, cosine being 1/2 gives me pi over 3. So I know it's negative, so the pi over 3 are my reference angles. They have to be here or here, the two negative signs of cosine. As far as answers go, this means if I start at 0 and go here, I get 2 pi over 3. And if I go the extra bit, I get 4 pi over 3. And again, the way I get that is I know this is 0, I know this is pi, because we're in radians. 0 on the right, half a rotation is pi. So this is just pi minus pi over 3 to get one answer, and that's the 2 pi over 3. And the other answer is pi plus pi over 3, which is 4 pi over 3. Okay. Now the last one is cosine of x equals 1. Well, here's 1 right here. This is negative 1. Cosine, remember, is the x value. So the only time cosine is equal to 1 is actually where it starts, at 0. We go around one rotation, but that's negative 1, that doesn't count. Go back here, and that's 360. So here theta equals 0, or, sorry, I keep on going to degrees. 0 or 2 pi. But remember, in our answer, they're only looking for answers between 0 or up to 2 pi, not including 2 pi. So they don't want the 2 pi answer, they just want the 0. Right? So we couldn't really, so again, cosine x equals 1. 1, that's where I got the 0 answer. Right. So as far as my solutions go, my solutions are 0, 2 pi over 3, and 4 pi over 3. Now, one thing I need to mention, it doesn't apply here, but I do have to mention it. Whenever you're solving an equation, if you introduce a variable to an equation, you have to check your answers after the fact. And in this problem, in order to solve it, I had to introduce cosine of x to the problem. Well, not really added in terms of added, but I would say introduced another cosine. Since I introduced another cosine, then sometimes you'll get what are called extraneous solutions. Answers that work for the equation with the new cosine in it, but don't actually work for the original problem. And so when that happens, you have to basically check your answers. And so if I go to my problem, it's 2 cosine x minus 1 equals secant x. Okay, and so you would check them. You would say, all right, 2 cosine of 0 minus 1 equals secant of 0. Well, cosine of 0 is 1, so you get 2 minus 1. Secant of 0 is also 1, and so that checks out. And then you do the same for all the others. 2 cosine of 2 pi over 3 minus 1 equals secant of 2 pi over 3. And so cosine of 2 pi over 3, that's the same as, so 2 pi over, I'm using this just to help me out. I'm going to erase it in a bit. Here's pi over 3, so 2 pi over 3, pi over 3, pi over 3. So 2 pi over 3 puts cosine in the negative side, and cosine of pi over 3 is 1/2. So this becomes 2 times negative half minus 1 equals, and the secant is just going to be the flip version, so negative 2. And so this gives me negative 1 minus 1 equals negative 2. That checks out. And then the last one is 4 pi over 3. And because of room, I'm just going to change this to a 4 pi. I'm going to change this to a 4 pi. And you can use a calculator if you want to check these out. But anyway, so 4 pi would be the pi over 3 that's over here. But for cosine, that's still in the negative side. So that's still going to be 2 negative 1/2 minus 1. Secant, it's the same thing. And so the math ends up being exactly the same. You get negative 1 minus 1 equals negative 2. And so everything checks out. And so all three of these solutions are good. Now, for now, this was the first example. So even in the textbook, they didn't check the answers. But I just wanted to mention that whenever you add something to an equation, you have to check your answers when you're done. Because you added to it. You never know if your answer is a solution to the added part or is this a solution to the original part. Got to be careful. All right. Anyway, let's go to the next one. So that was our first problem. The next one, solve sine of 2 theta plus square root of 2 cosine theta equals 0. Now here we're in degrees. So first we're going to rewrite this. We learned that this is just 2 sine cosine plus square root of 2 cosine theta. And we can see that we can actually factor a cosine out of each expression. That leaves us with 2 sine theta plus square root of 2 equals 0. So cosine theta equals 0 is one answer. 2 sine theta plus square root of 2 equals 0 is the other answer. So if I solve for sine theta, I get negative square root of 2 over 2. So these are my two terms that are going to give me my solutions. Notice I didn't add anything to this expression in order to solve it. Like I didn't introduce another cosine or another sine. I didn't divide by anything. So my answers are going to be my answers. I don't have to check in this case. So cosine theta equals 0 is what I get here. Sine theta equals negative square root of 2 over 2 over here. So where is cosine theta equal to 0? If I go to my table, cosine theta equals 0 at pi over 2. Pi over 2, this is degrees, so pi over 2 is 90 degrees. Okay, so cosine theta equals 0 here, and then also here. So we got 90 degrees, and then we got 270 degrees. Not 27 degrees, 270 degrees. So those are my two solutions for this problem. And then sine of theta is negative square root of 2 over 2. Well, the reference angle that does that is 45 degrees. Sine, I know, is positive up here, negative down here. So my two angles are going to be 45 degrees this way, 45 degrees this way. And so my answers are going to be, it's going to be a rotation plus 45 degrees. And the other one's going to be a full 360 minus the 45 degrees to get the other one. So 180 plus 45 is 225 degrees. And then 360 minus 45 is 315 degrees. So those are my four solutions. If you wanted to write them all nice and pretty, you would say 90, I guess I can put them in order. 90 degrees, 225 degrees, 270 degrees, and 315 degrees. Yay! And again, these are all some things you can check in Desmos too. Now, I don't say use Desmos to cheat, but there are ways that you can check your answers. So for instance, this problem was sine of 2 theta plus square root of 2 cosine theta. So sine of Desmos, you have to put 2x plus square root of 2 cosine x. Okay, so you get this weird looking solution. We're in degrees though, so I need to switch this to degrees. Projector mode, turn off the grid. And we want to see where this equals 0. So equals 0 means where it is across the x-axis. So negative 360, 360. And so if you look at it, boom, there's one answer. Boom, there's the other. Boom, boom. So 90 degrees, 225, 270, 315. Yay, math. All right, so that's it with that for that page. Let's go to the next page. So I have solve 4 cosine squared x plus 4 sine x equals 5. Now this is set up like a quadratic because we have a cosine squared and a cosine. So I'm just going to subtract the 5 so that I can complete the quadratic. All right. Now, here, my variable is sine of x, and I know that I can change this to be in terms of sine. So I'm going to go ahead and do that. Cosine squared x is 1 minus sine squared x. And from there, we just kind of crank it out and see what we get. So distribute the 4. And we have some like terms here. We got 4 minus 5 is negative 1. And if I wanted to, I don't like it leading with a negative, so I'm just going to multiply both sides by negative 1. Because why not? All that does is that changes the signs to 4 sine squared x minus 4 sine of x plus 1 equals 0. Now notice that this here is a quadratic that I can hopefully factor, and it turns out it is factorable. If you don't like to factor, you can also use the quadratic formula. I'll do that on the side in a little bit. But this ends up being 2 sine x, 2 Sine x, that's one way to get 4 sine squared. To get a 1 at the end, these have to be 1 and 1. But the middle term is negative. So the only way the middle term can be negative, but the last term be 1, a positive 1, is that these are -1 and -1. And so if you look it up, 2 sine x times 2 sine x, 4 sine squared x, minus 2 is -4, plus 1. And so this works out. So notice that this is the same thing. If this was a college algebra class, we would go into multiplicity. But for now, no multiplicity. We're just trying to find the answers. So we have 2 sine x minus squared equal 2 sine x minus 1 squared equals 0. I can set this equal to 0. And so this means this is where sine of x is equal to positive 1/2. I just added 1 divided by 2. And so this is where sine of x equals 1/2. Now, again, if you wanted to, you could have used the quadratic formula. Looking at this problem, I could have seen that a equals 4, b equals -4, c equals 1. So if you wanted to, if you don't like factoring, you could have just used the quadratic formula, which would have been sine of x is equal to negative b plus or minus the square root of b squared minus 4, a times c is 4, the whole thing divided by 2a, which is 8. And notice that when you do this, you get 4 plus or minus 16 minus 16 is 0. And so you end up getting 4 plus 0 over 8, 4 minus 0 over 8, or in this case 4 over 8, which is just 1/2. So you can use the quadratic formula if you want. Notice that you just get one solution. But sine of x equals 1/2, sine of x equals 1/2. It doesn't matter how you approach it. But if you don't like factoring, that's the way to go. So anyway, where is sine of x equal to 1/2? Well, I know sine is positive, positive, negative, negative. And 1/2 is 30 degrees. In this case, this is in radians, so pi over 6. I didn't add any variables to this equation. Yeah, I multiplied by -1, but that's not introducing a variable, an x or anything. So my answers here are theta is equal to pi over 6. And then the other one is a full pi, but minus pi over 6. So this here is 5 pi over 6. There you go. Those are your solutions. Oh, and this isn't theta, it's x. Sorry. All that work for those two answers. Anyway, hopefully that wasn't too bad. Notice the biggest part for this was the manipulation. There was a lot of algebraic manipulation to get to the final answer. Let's keep chugging. So sine theta minus cosine theta equals 1. And we're in radians again. So here, in this problem, let me rewrite it. Okay, now if they were sine squareds or cosine squareds, I could make substitutions. But as far as substitutions for just sine theta, cosine theta, I can technically make some, but there'd be square roots and all these nasty stuff involved. So what I'm going to try to do is I'm going to try to make them squared so I can have easier substitutions. So before I do that, I can't just square because then you get this nastier looking answer. What I'm going to do is I'm going to add the cosine to the other side, and then I'm going to square it. So at least it'll look a little nicer. You don't have to. Actually, I'm doing it the way the book did it. I'm kind of interested what'll happen if you just square both sides starting from there. You probably get something that works out. Anyway, just sticking to the book. Sine theta equals 1 plus cosine theta. Okay, so now that each one's on its own side, I'm going to square both sides. Okay, so that means that on the left, I'm adding a sine squared. On the right, I'm adding a 1 plus cosine squared. I'm adding to the equation. So basically, this is sine theta times sine theta. And I'm going to put that in red. The main thing here is when we're done, we're going to have to check our answers. Because there wasn't another sine theta in the problem, I'm artificially adding it here. And the same thing over here. There wasn't a cosine theta in the problem, and I'm adding it in there. So whenever you add a variable, I have to check solutions. All right, but anyway, so we work it out and we get sine squared theta. Here, I would have to FOIL it out, and I get 1 plus 2 cosine theta plus cosine squared theta. Okay. Now, since cosine is the variable that's here, I can actually turn everything into cosines so that I can work with it. So this term right here, sine squared theta, I'm going to change that to be 1 minus cosine squared theta. All right. Now I can add a cosine squared to both sides. And I can subtract a 1, which actually will just kill those terms off. And I'm left with 0 is equal to 2 cosine theta plus 2 cosine squared theta. They both have a 2 cosine theta in common. And that leaves me with 1 plus cosine theta. Tricky, tricky. And so let's finish this off. I ran out of room, so I'm going to kind of go over here. Oh, that should have been a 0, not a theta. Okay, so each one of these is going to be equal to 0 now. That's going to be equal to 0, and that's going to be equal to 0. And those are going to be my 2 separate problems to solve. So 2 cosine theta equals 0, and 1 plus cosine theta equals 0, divided by 2. Cosine theta equals 0, and then the other one, cosine theta equals negative 1. All right. So let me see if I can move stuff around a bit. So here, this is my cosine theta equals 0. This is my cosine theta equals negative 1. So in solving the first one, when is cosine equal to 0? Well, that's where x equals 0. And so that's going to be here and here. Remember, cosine is associated with x. Here's 1, negative 1, and in the middle, x is 0. Let me get rid of this. It's in the way. Right? So x equals 0 is in the middle. And so the angles that give me that are going to be, we're in radians. So we have pi over 2, and the other one is 3 pi over 2. Okay, Where does cosine equal -1? Well, there's only one place where that happens. And that's at pi. So I have three solutions, pi over 2, 3 pi over 2, and pi. But because I added a sine of x and a 1 plus cosine x to the problem, meaning that they weren't there before, but in order to solve, I added them to the problem, I have to check my solutions to make sure everything's okay. And so what you do is you plug into the original equation. You know what? I'm going to do some arranging so I can make this kind of look nice. Don't you wish you had a computer where you can write on too? Tee-hee. Let me delete that. Did it delete it? Delete. Okay. All right. So now I have actual room to go here. So to check our solutions, you always plug into the original. And so if I plug into the original, my original is sine, so it's going to be sine of 1 minus cosine of 1 equals 1. If it works out, then it's a solution. If it doesn't work out, it is not a solution. So for the first one, I'm going to try pi over 2. Well, sine of pi over 2, so sine starts at 0, it ends at 1, so this is 1 minus cosine, this is 0. 1 minus 0 equals 1. That checks out. Yay. I can try another one. Let me shrink that and kind of move it to the side. Now we can do it again with the other answer. Sine of 3 pi over 2 minus cosine of 3 pi over 2 equals 1. Okay, at 3 pi over 2, we can kind of use this point to help us out. This is the angle that gets 3 pi over 2, and the value is 0, -1. So the sine value is -1. The cosine value is 0. And notice that that does not work. You get -1 minus 0, and that's -1 equals 1. So this is not a solution. So that means that we have to toss 3 pi over 2. Sad days. Now notice if we squared both sides, it would be correct. 1 equals 1. That's why the squaring both sides changes the equation. So squaring both sides, it would have been correct, but since the original problem, the sides weren't squared, it's not a solution. And so now I go to the last one, and the last one says just pi. So sine of pi minus cosine of pi equals 1. Sine of pi is 0. Cosine of pi is -1. And notice that you get 1 equals 1, so that is a solution. And so my real answers are, where did I go? There we go. Are just pi and pi over 2. So you got to watch out. Whenever you introduce material to the problem, you have to check your answers to be sure there's not any fake answers in there. All right. Let's do one more and then we're done. Gus wants me to go to sleep. Hey, Gus. I know, you're a good kitty. So, this last one, solve sine theta over 2 plus cosine theta equals 0. So here we're going to use the half angle identity. So here I'm really bad at drawing big square roots. So this is 1 minus cosine theta over 2 plus cosine theta equals 0. All right, so you can tell by the square root that I'm going to have to square both sides, which means if I square both sides, I'm going to have to check my answers when I'm done. But before I square both sides, I want to move this to the other side to make my life a little easier. So plus or minus square root 1 minus cosine theta over 2 equals negative cosine theta. And now I'm going to square both sides. So I get this entire side and I square it. Sorry. Yeah, there we go. So I get this side and I square it. I get this side and I square it. Again, because I squared both sides, that means I have to check my solutions. All right, but anyway, what the squaring does, it gets rid of the square root. So I end up with 1 minus cosine theta over 2. I square that, so that just turns into a positive cosine squared theta. And now this is a quadratic that I just have to unravel. So I'm going to multiply both sides by 2. So I have 1 minus cosine theta equals 2 cosine squared theta. And then I'm just going to move everything to the right side. So I'm going to subtract 1, and I'm going to add cosine theta. Let me shrink everything again. Okay, so if I do that, I get 0 is equal to 2 cosine squared theta plus cosine theta minus 1. And that is happily factorable. That ends up becoming 2 cosine theta minus 1 and cosine theta plus 1. Yay! So solving for this, I have cosine theta equals positive half, cosine theta equals negative 1. So those are my two answers that I'm going to try to solve. Now I know cosine is positive on the right, negative on the left, positive on the right, negative on the left. And I got to find my answer. So where is cosine equal to 1/2? Going way back to the beginning, because I already forgot. Cosine is 1/2 at pi over 3, or 60 degrees. Here we're in degrees, so 60 degrees. All right, so my answers here are going to be 60 degrees, and then a full rotation minus 60 degrees. And so that's 360 minus 60, which is just 300. So the angle from here to here is 300 degrees. 360 minus 60. Now, where is cosine theta equal to negative 1? Well, we did this one earlier. Here's 1, here's negative 1. Cosine is the x value. So where does that happen? That happens at 180 degrees. All right, so those are my solutions, but now I have to check. And let's bring in the calculator for this one, just, I know a lot of people don't like having to, checking is never fun, let me put it that way. All right, so first I'm going to check with 60 degrees, so I make sure that my calculator is in degrees. It is. And so I do sine of 60 over 2 plus cosine of 60. And I hope to get 0 at the end. Notice that here I got 1, so 60 is out. Wah, wah. And so now I'm going to try 300. So sine of 300 over 2 plus cosine of 300. Also got 1. Wah, wah. So now I do 180. Where's my sine? Sine of 180 over 2 plus cosine of 180. Yay! And so this one actually worked out. So my only solution here is 180 degrees. Dun, dun, dun. So remember, every time you add a sine or a cosine to both sides, or every time you square both sides, you have to check your answers when you're done. Okay, you're probably going to see one of those on the exam, where as multiple choice, one of the answer choices will say 60, 30, 180, and the other answer choice will just say 180. Dun, dun, dun. They got you. So you got to watch out. All right, anyway, that's it for today. Try out the other 3 problems on your own and see what you get. Other than that, y'all have a good one.